All right, 611 here, guys. We're going to be able to solve different types of equations. We can use any method we'd like. A lot of times, though, we're going to use that traditional inverse operations method. And some of these are going to be multi-step, so they take a couple of steps to solve them. So let's start getting through this and talking about these here. The first one, again, they've kind of got the answer over here. We think of that, but this is 1.9 plus r has to equal 4.3. So I'm trying to figure out what r has to be to make this true. And we learned that if I add 1.9 to r, again, I like to flip this to r plus 1.9 equals 4.3. Again, if I add 1.9, how do I undo that? I would subtract 1.9 to undo it, and that leaves me with nothing. So I'm just left with r plus 0, which is r. And if I subtract 1.9 from this side, I'm going to subtract 1.9 from this side, and it'll stay balanced. Okay, and I've already done the work here. You guys can line it up and do your subtracting here, but the answer should be r equals 2.4. That'll be my answer here. And r equals 2.4, and we talk about that check step. If I plug that in, I've got 4.3 should equal 1.9 plus r, the original thing, equation there, and we know r is 2.4. And I know if I add those two, it will equal 4.3. All right, so I plugged it in. I know that that is correct. So I know r equals 2.4 in this case, or 2 4/10. Question B, a lot of people make mistakes on question B. They see the division bar, the fraction here, and a lot of kids will take 14 divided by 3, and that's not what this says. It says what number, h, divided by 3 will get me to 14. So I should be thinking h has to be 3 times bigger than 14. All right, because the answer comes up 14. It doesn't say 14 divided by 3. But if I'm using my traditional work here, I've got h divided by 3 equals 14. Remember, I took h and divided by 3. How do I undo that? I multiply by 3. If I divided it by 3 and then multiplied it by 3, it's like it didn't happen. Inverse operations. So I'm left with h. If I take that times 3, I must take this side times 3 to keep it balanced, and to get h equals 42. So again, there's my answer. H equals 42. And the check step, again, plug it in. So I'm going to get rid of h here, and I'm going to put in 42. 42 divided by 3 is 14. So I know I'm correct. All right, so that makes sense. So be really careful. Kids struggle when they see those fractions, or it just means divide. We should have a number that's bigger there to make that true. So 42 makes sense. Okay, so make sure you've got these written. I'm going to scroll up and we'll look at the last two. We'll pause the video if you need to here. All right, question C. We've got 3/4 times y plus 6 has to equal 18. So here's that multi-step problem. And we learned that this is 3/4 times y plus 6 has to equal 18. So probably going to use inverse operations with this. We know if we add 6, to undo that, we subtract 6. Because 6 minus 6 is nothing. So that leaves me with 3/4 y equals, and if I subtract 6 from that side, I must subtract 6 from that side to keep it balanced, just like the pan balance. And 18 minus 6 is 12. All right, so some kids get confused with this as well on how this works now. Okay, just because it's a fraction, don't let that fool you. This is 3/4 times y, or y times 3/4. If I multiply y times 3/4, how do I do that? I divide by 3/4. Okay, if I take 3/4 divided by 3/4, that's 1. And 1 times y is just y. If I multiplied it times 3/4, I divide by 3/4 to undo it. So I must divide by 3/4 to undo this. And it kind of looks weird because that's a fraction or a complex fraction. I could have written it like this. 12 divided by 3/4, right? If I divide by 3/4 here, I divide by 3/4 here. And then I can use that reciprocal to help me find my answer here. So remember, instead of dividing, the first number stays the same. Division can change to times, and I flip it to 4/3. Worked on that in that last earlier this year, and working on dividing of fractions. So really, I'm just taking 12 times 4/3. So I put a 1 under that. Remember, we can multiply across. 12 times 4 is 48 over 1 times 3 is 3. And then I can take 48 divided by 3 to get my answer. And 48 divided by 3 is 16. So I know y equals 16. And if I plug that back in, I plug it back in up here. And I'd have to 3/4 times y is 16 plus 6 must equal 48. Okay, and if I do the work, 3/4 times 16 plus 6 will get me, excuse me, not 48, 18. And 3/4 of 16 is 12. Okay, I know that, but you guys can do the math if you had to. 3/4 of 12 or times 12 is, or of 16 is 12. So 3/4 of 16 is 12. And plus 6 equals 18. So we know that we did it correct, and y has to equal 16. Okay? All right, one more here. We've got some decisions to make on what I get rid of first. There's different ways I could do this. I see, like, if I have 58, take away 5p, I'm going to add 5p to undo that. If I take it away and add it, that's like it's not there anymore. So then I have to add 5p on the other side. So that becomes 9p plus 22 on that side has to equal 58. So if I subtract and then add it, it's like it's not there. I undid it. So I add it over here. Now I have 9p's plus 22 equals 58. Then we get that's in a pretty simple form now. If I add 22, I know I want to get p by itself, so I have to subtract that 22 to get rid of it, and that just leaves me with 9p. And if I subtract 22 from one side, I do it to the other to balance it. And 58 minus 22 here is 36. And now I'm thinking 9 times what gets me to 36? And some of you just know that p would be 4. But we know we could also, to undo multiplying, we divide by 9. So if I divide by 9, that leaves p by itself. So I divide by 9 here. So p equals 4. And I know that is correct. If I plug it back in here, and again, I'm not going to take the time to substitute right now, but we would know to plug that back in to make sure it worked and both sides would equal out. Okay, we've done that on all the other ones. So that's something you make sure you do every time to see if your answer makes sense. So p equals 4. All right, so make sure you get these copied down here.